For my research design, I will go through details in each objective. Objective 1 is to understand agriculture producers' climate information uses to improve climate change communication gaps between scientific communities and agriculture producers. To do that, I will identify climate data sources, information types, and accesses preferred by agriculture producers for information farm decisions and understand how producers comprehend climate information in cartographic methods. The theory for the theoretic framework is the elaboration likelihood model. To find the differences between high involvements and low involvements group to use climate information. Qualitative and quantitative methods are adopted in this phase. Interviews will help to understand the rationale of climate data uses, and survey methods will help to gain understanding the data use and spatial differences among the use. The design research used a non-random sample for interviews. There are 4 sets of questions. The first 2 sets of the questions were more structured to get an overview of the agriculture producers' demographic and farm operation information. The last 2 sets of the question were more unstructured and open-ended to examine how agriculture producers interpret and visualize climate information in their decision making, and to determine what factors enable or hinder this process. The semi-structured interview questions only helped to guide the interviewees, allowing the conversation to be partly guided by their thought processes. Such an approach was crucial, but it allowed the discussion to go beyond simple dichotomies. Use or not use the weather climate information, trust or not trust what sources to elicit a more qualified understanding, how to get the information, why to use it, and what forms they prefer of how the information being delivered and used. An institutional review board (IRB) application was submitted to the Kansas State University Research Appliance Office, who determined this work was exempted. The Department of Agronomy faculties and research extension specialists were serving as liaisons to help make connections with county extension agents and field day agents through the state. A total of 30 in-depth interviews were conducted in 2005 between May to December. Informed consent was obtained from each interview participant, and all survey data collected remain strictly confidential. Anonymity of the respondents was maintained, and interviews were audio recorded and transcribed. Most of the producers shared more weather use information than climate information, and they tended to spend more time and effort to share their life and farm experiences, since weather data impacts their day-to-day lives. When they talk about climate, they felt they did not have much to say because they did not access climate information as often as weather information. Only a few producers shared a lot of climate information with the investigators because they really enjoy learning it. Moreover, the information analyzed could be biased due to the producer's interests. Another limitation is a low number of participants. These participants were mainly from the northeast and southwest areas of Kansas, which does not represent the views of the entire state and their climate consumption information. We provided qualitative data consumption information among producers on data sources, formats, and preferences, types, parameters, and accesses. However, further quantitative studies are suggested for a better understanding of the consumption of climate data. Further work such as survey methods could enlarge the population size to better investigate spatial variability differences in climate data use. Interview results on climate data use in the climate cartographic visualization methods were used to generate a survey to gather data use opinions from agriculture producers. Questions are designed to gather producers' demographic information, including their geographic information, zip code type in. A scoring system is designed using a Likert scale from 1 to 5 for climate data sources, formats, types, and accesses. The data formats are accessed through several principles of climate cartographic design, including principles concerning map layout, visual hierarchy, visual variabilities, position, size, color, value, texture, color hue, orientation, and shape. The survey link will be sent through Kansas Agronomy Department e-updates, email listserv, and postcards. Informed consent will be obtained from each survey participant digitally. An IRB review board application was submitted to the Kansas State Research Compliance Office in April 2016 for this survey, which will be conducted using Kansas State Survey Services powered by Quandrix. According to Kansas Farm Facts, there were 61,800 farms in 2013. In order to have a confidence level of 95% at 5 confidence interval, and the survey sample size needs 385 respondents. Internet World Statistics shows that total population in 2015 is 2,917,312 and internet users were 2,002,270,721, which is the 78.9% of the population. The goal of Objective 2 is to develop a limited geospatial climate decision support system based on the previous data use preference research. I will use the climatological network data import into GeoDatabase and then finish the dynamic analysis with modeling and mapping application. Two communication theories are guided for this application design. Anticipated results for this step is the Kansas Agroclimate website. Framing theory will be used to support the communication text and value based on cartographic design principles. A clear visual hierarchy, simplicity, eligibility, consistency, accessibility, and good composition. Visual communication messages should be simple, noticeable, understandable, memorable, and emotionally charged, with framing as a means of making sense of issues. Framing can translate the science, making the invisible process of the changing climate variable while rendering the abstract concrete. The rationale to use framing is combined with the cartographic visualization, the cognitive usability of the visual products. Based on that, a second communication strategy is applied using construal level theory. Construal level theory is a theory in social psychology that describes the relation between psychological distance and the extent to which people's thinking about objectives and events, and abstract or concrete. This theory is adopted in this research to understand where the perceived psychological distance influences coastal level for climate information through geovisualization methods at spatial, temporal, social, and hypothetical levels. It also targets spreading climate information, which scientifically accurate visualization and cartographic interpretations that connect the dots from changes in farm-level weather patterns, environmental conditions, and extreme weather events to climate change, as well as successful adaptation strategies among agriculture communities that have already implemented solutions. All datasets will be made publicly available online through the Kansas State University maintained Geographic Information Systems Spatial Analysis Laboratory website, and as a cooperation with Kansas Office of the State Climatologist. Objective 3 is designed to evaluate the climate data visualization methods and geospatial climate support decision-making system. Two criteria are selected. The first one is Former and Boch 2004 Application Usability and Effectiveness, and the IPCC 2012 Special Report Evaluation Rubric. Evaluation workshops lasting 2 to 3 hours will be held in the Kansas Research and Extension Centers using a multimedia PowerPoint presentation with the application and products. Evaluation methods used standard social science assessment techniques: pre-post survey, written questionnaire, written qualitative comments, and participant observations to determine changes in participants' attitudes and knowledge due to the presentations and producers' opinion on the process.